Back again. For this session, I have a new guest. It's Sanita Maslovska, who is joining us from Latvia. Hi, Sanita. Good
Hi,
afternoon.
Daria. Hi,
Hi.
good afternoon.
Sanita is going to talk today about the carbon footprint calculations. We are always happy to receive your questions in the Q&A part of this chat. Please do that during Sanita's presentation as well as afterwards. Sanita, with saying that, the floor is yours. Enjoy the
Thank you,
presentation,
Daria.
everyone.
Thank you. Yes, so hello, everyone. Very excited to speak to all of you today. As Daria said, I'm Sanita Maslovska, and I am the Sustainability Process and Knowledge Specialist for allnex. And for more context, I should say that I am in the Product Sustainability and Regulatory Affairs Department. So in my everyday work, I mostly deal with product level sustainability issues as opposed to company level. And so that's to say that this talk is also about the product level carbon footprint. All right, so let's start with, first of all, what is a product carbon footprint? I'm fairly sure that most of you have at least heard about it. So you will know that it's nothing that you can directly measure in a product. It's something that you have to calculate using quite a few data points because it is the sum of all the greenhouse gas emissions throughout a product's life cycle. And that starts at the material extraction. So those are the primary materials like naphtha or natural gas, anything that's mined or coming from a recycling stream or grown. So what you have to take into account is not only the process itself, but also what would have been on that land. And this is particularly relevant for something that's grown or something that's mined. So what would have been on that land had there not been this mine or, for example, soybean plantation? All right, so that's taken into account in the scope of a product carbon footprint. What's next? Then, of course, any material needs to be transported somewhere. And transportation famously, of course, also has a carbon footprint. And depending on the mode, there's more or less, but transportation also definitely is taken into account. So where is it transported to? Most likely some next processing stage. And this next processing also is associated with some energy, and that is also usually carbon footprint. And it also might have some greenhouse gas emissions in the processing itself. So that is all summed up in each of the next processing steps that accumulates the carbon footprint until it gets to allnex, which is also just another processing step. And here we also add our operational emissions and how we contribute to that product carbon footprint. And this is where we draw the line at our gate. So when a product leaves the allnex gate, and we call that, well, everyone calls that the cradle to gate product carbon footprint. And we do realize that we have an effect after allnex. There is life after allnex, but there's a very good practical reason why we report to cradle to gate is because, first of all, anything that happens downstream from us, we can only make assumptions about that. So it's the player right after us that will know best exactly what will happen to that material after the allnex gate. And also, it's easier for communication if every player in this chain reports the same thing, then it's clear that you report on what you definitely know happened, or at least you can get data and you can strive to know exactly what happened up to your position. And so we can all sum it up without making any unnecessary assumptions. For the chain, however, unnecessary really not the case. Uh, as I said, we have an impact downstream, and we are working with our customers on several projects to evaluate exactly what that impact is. One example of that would be the energy required for curing our products. So we can strive to lower that, of course. But how would we do that? Maybe it would involve using a raw material that has a higher carbon footprint. So there needs to be really an evaluation of the entire life cycle of a product. And since we realize this, our R&D department has a requirement to estimate the environmental impact of all its projects. So, of course, the more environmentally favorable projects are going to be prioritized. And if something has a negative effect, it will not even be considered. Right, so back to that scope. Um, it looks like a very clear, rigid box, but in fact, and this is a hope for the future, uh, we will strive to get more supplier specific data. And what that will come with is also kind of an expansion of that scope. So, what I mean by this is that, for example, that soybean plantation that I mentioned before, they could decide to include their office supplies in their scope. Of course, this will have a negligible effect. And by the time that that number gets to allnex, it will have disappeared probably behind many, many zeros. But in effect, that's an expansion, broadening of the scope. And in an ideal world in the future, when we have all data from suppliers, then this scope could effectively be infinite. And another thing I want to note is that this product carbon footprint that we will report, it is site specific. Why is that? Well, because the raw materials that arrive at each site already, they are different. They come from different suppliers. They have taken different routes to get there. So they have a different carbon footprint. And of course, as well, the site itself has a different carbon footprint. So some sites are more or less energy efficient. Some sites use more or less green electricity or energy. And this is where we have our first line of attack to lowering our product carbon footprint. And allnex has a commitment here, an ambitious one, I would say, to lower its scope 1 and 2, and that's according to greenhouse gas protocol. That's the emissions that occur directly in the site and from purchased energy. So we're going to lower those by 30% by 2030. So this is line one. So what other ways can you think of to lower a product carbon footprint? I'm sure you've all heard of using bio-based materials. This is very popular these days. So how does lowering a carbon footprint with bio-based materials work exactly? So what are bio-based materials then? Bio-based materials, mostly those are going to be plants. And what do plants do during their life? They take CO2 from the atmosphere, they incorporate it in their biomass, and this biomass then travels through the value chain up until the end of life of a product. And then one of several things can happen to it. It can be, for example, burned. So if it's burned, assuming that it's perfect combustion, you will have CO2 that's emitted. So you had CO2 that you took from the atmosphere, and now you're giving CO2 back to the atmosphere. So that's a net zero effect. Then it could also be landfilled. When it comes to landfilling, it does get a little bit more complicated because there it depends on the landfill, whether it's closed, whether it's open. It also depends on the material, whether it's biodegradable or not. And a note on biodegradability is that it has no relation to being bio-based. Something that is from fossil resources can also be biodegradable and vice versa. So assuming it's biodegradable, yes, then you could also have it be eaten by methanogenic bacteria, and you can produce methane, which is an even more potent greenhouse gas than CO2. But assuming that you landfill in a closed landfill and you have a material that's not biodegradable, what you've done effectively is you've buried carbon. So you've taken carbon from the atmosphere and you've put it underground, so you have a net negative effect. Similarly, with recycling. Also, you are not creating any emissions, you are avoiding them by letting the carbon continue its path in the value chain. So, when it comes to um, bio-based materials, and in fact, all materials, um, what I think is important is that we do not forget that all these blue dots here that you see, all the other footprints from transportation and processing, those haven't gone anywhere. Those haven't disappeared. Those are still there and they're still relevant. So we shouldn't get lazy just because we're now subtracting CO2 from the atmosphere. We should also keep the other effects in mind and strive to lower those as well. And another thing I like to note, also valid for all materials, is that carbon footprint is not the only effect on the environment. We, of course, have other impact categories, and always a full life cycle assessment is the best thing to do. It is more complicated. But just as an example, you can imagine that soybean plantation is going to have quite a bit of effect on the land that it's on and the ecosystem around it. So back to the bio-based carbon footprint, though. When we report our product carbon footprint to you, what you will actually get is three different footprints. So one of them is going to be the biogenic uptake, which is that CO2 subtracted from the atmosphere. The second one is going to be all those blue dots, so the net fossil carbon footprint. And then you'll also see the total carbon footprint, which will be the sum of those two. For your calculations, you're likely to also need the bio-based carbon content or the biogenic carbon content and the total carbon content. So we will also provide those. All right, so what else could be a way to lower a product carbon footprint? I'm sure you also thought of this one already, and it is, of course, recycling. So, recycling, of course, has benefits beyond the carbon footprint. Circularity is something we should strive for just as a more efficient way to use the planet's resources. But when it comes to just the carbon footprint, how does it work exactly? Well, if we use, and which we do use, and most of the industry actually uses, a specific allocation method when it comes to allocating emissions to something that's recycled. If we use the allocation cutoff by classification method, and I'm using the EcoInvent terminology here, if we use that, then that material, when it goes to the recycling bin, all its past sins are forgiven. Well, they're not forgiven. All the emissions are attributed to its previous life. So when it comes out of the recycling bin, it has a carbon footprint of 0. Of course, it needs to be processed. It needs to be actually recycled. And in that process, it starts accumulating its new carbon footprint. And depending on what material that is and what you want to get out of it, there are very different technologies, as you probably very well know, and they have very different energy demands. So, very different carbon footprints. But in general, the material, by the time it arrives at allnex, is likely to have a much lower carbon footprint than a virgin material. So that's one way that we at allnex can lower the carbon footprint, but that's not the full story. Of course, recycling, as I already mentioned, has a benefit down for the downstream players, so the end user can decide to recycle, as I said, effectively avoiding emissions. And here is also one of the ways that we can contribute. So allnex can strive, and we do, to produce products that are either easier to recycle themselves or at least do not inhibit recycling of the substrate. So that's one way, again, that we contribute. And by now you see that calculating the carbon footprint really is a complex thing. without even going into more detail, and that it requires a lot of data management. And we are also not a very simple company. We have quite a broad product portfolio. We have over 4,500 products, and we offer them in 12 different packagings, and we produce them in 27 different sites. So that amounts to about 8,900 individual product carbon footprints. And if we would like to calculate that every 5 years, which is the generally accepted validity period for a carbon footprint, we would need a small army of people to do that. So, of course, automation is, I think, inevitable here. And this is exactly what we're doing. We are in the pilot stage with a company that provides just such a tool. What this tool does, it takes information from different systems that allnex uses, and that would be so production and transport data from our ERP system, SAP. So that's bills of material, volumes, and the locations where between which things are being shipped. Then it takes also plant data, which we now keep in UL 360. And these are energy consumptions on the site, and then the different emission factors for each energy type, and also how much waste we've created, and so on. Then the tool would also, of course, take the supplier data, well, the raw material data that we would have gathered. So first of all, from suppliers, which is the primary data, which is the preferred data to use. Um, and if we don't have supplier data, it would take data from generic databases, like, for example, EchoInvent. And if we even don't have that, then we'll use assumptions, either extrapolations from data we find in EchoInvent or expert judgment and other assumptions. So the tool will put all that together in an automated product carbon footprint. And what that will allow us to do is to have an overview of our portfolio so we can know exactly where we could do improvements. And when we do make those improvements, we could notify you. In fact, we could notify you every year because we could make yearly product carbon footprints. And so, by which year, by when do we plan to have this wonderful tool for all our production sites? What that would be by the end of 2023. And I really cannot wait. And that's it for my presentation. I am ready for your questions.
Thank you very much. Yes, I'm here.
Great.
Thank you very much, Sanita, for presenting today. And now, everyone, it's time for Q&A. So, Sanita, the first question for you. Which tool is that you are implementing, the one that you mentioned? What is this tool? Can you please
Yes,
elaborate on that?
this is the bearing point emissions calculator.
Okay.
Yeah.
Thank you so much for answering this. The next one. Well, thinking about the inventory reduction overall, we see that often we end up in different air freights, especially when the demand is there. Yeah. How to address this in a day-to-day business? What can we do about that? How can we tackle that problem?
To reduce air freight.
That's correct. Yes.
Well, that would be more a question for planning, I imagine. But first of all, we have to foresee it. That's the only thing that I can say about it so far. Um, this tool, that's one of the things that this tool will allow us to see inefficiencies in our logistics and to tackle them, and that's definitely one of those things.
Thank you, Sanita, for answering this. Is allnex aligning its product footprint calculation to the newly published TFS guidelines?
Yes, Yes, we definitely are. Of course, we are, because this is so far the most industry. This is an industry-specific guideline, so we will definitely try to follow it.
Thank you for answering this one. And we go to the next question. Which standards are you using?
Oh, well, now that there's the TFS guideline, we will be really basing our reporting and calculations on that. And that is based on the ISO 14000 series, so ISO 14067, and also the Greenhouse Gas Protocol, and also the PEF, the European.
Thank you. And we go to the next question. Will you have certification of your product carbon footprints?
Yes, we plan to. We do not have a specific certifier in mind yet, but that is part of that implementation process of this automatic calculation.
Thank you for taking this one, Sanita. And we go to the next. Can we get any website, or can you name any website where we can get calculation on footprint?
Website. If only it would be that easy.
Yeah.
I wish that if I would know a website, we would skip this whole implementing a tool. It is really not that easy. There are some online tools that offer it, but um, they mostly involve quite a bit of manual effort for data input. Um, yes, something like that is a quick Google search away, but a tool that would automatically read data from your systems, that is research that really takes some time. And you also have to find one that really fits your needs. So there's no one answer, sadly.
Thank you for answering this one. And we move to the next. Sanita, could you imagine an allnex product solution with a certain PCF which gets lower over the product life when compared with a standard market solution?
Over the product's life, in what sense? So through the life cycle. So I wish I had a little bit more explanation on that question, because certainly something that would last longer would have a longer lifespan, uh, uh, and therefore over the whole life cycle would have a lower carbon footprint, regardless of the materials used. There are so many ways. There's so many levers you have in the footprint control that you can pull up or down, and that affect the total product carbon footprint. So you really have to look at it as a whole.
Thank you. And we move to the next question. How do you handle today urgent requests from OEM customers about PCF from our range?
Yes, well, today we have a colleague doing those manually. So at the moment, it is via just Excel. But it is nonetheless just as valid when it comes to being adherent to standards. Uh, we use, of course, we have requirements for the data quality that we use. We do not just send out any number from random sources. Of course, we still have that same report that describes the quality of the data. And if it needs to be something really quick, sometimes we do give a range, an estimate, and say that we'll get back to you if you just really need something right now. Because a lot of the times, the problem is on data availability for raw materials. That's mostly the problem.
Thank you, Sanita, for answering this as well. And we move to the next question. Rough estimate is requested, Sanita. How much the transportation impacts over the total overall? rough estimation.
Yeah, transportation, at least directly to allnex, has a very, very low impact. So much so that it could even in many cases be neglected. Yeah. Um, Most of the impact comes from raw materials. Even our own operational footprint is about well, it really depends on the range, but about 10% on average. So yes, raw materials is really key.
Thank you for answering this one too. And we move to the next question. The tool that you mentioned will be implemented by end of 2023. Does it mean that each current PCF request would have to be calculated manually? And are you prepared for that?
We are preparing. We realized a while ago, and we now do have a colleague that whose main task it is to do these calculations until this tool is up and running. And frankly, he will not be out of a job after then either, because any automatic tool still needs input from a human being. But until 2023, yes, this will be done manually.
Thank you, Sanita. Do you need external verification for the PCFS?
The EPCF, sorry,
The
EP.
PCFS, the
Oh,
PCFS.
I'm wondering what the S stands for, but the PC, product carbon footprint so far. Oh, maybe the plural. Okay, got
Yeah,
it.
I believe it's the plural.
All right. Yes, you could. You're not as of now legally required to have, um, but it is definitely uh, more legitimate if you do have verification.
Thank you for taking this one. What is the difference between PCF
Hmm.
and ICA?
ICA.
This
And what does
acronym is,
ICA stand for? Um,
I believe it's LCA, Sanita. It's
oh,
a typo. I
LCA.
believe it's LCA. I apologize.
Okay. LCA is a life cycle assessment. And in fact, a carbon footprint is just one part of a life cycle assessment. So it's the single impact category of global warming. So carbon footprint only looks at that versus an LCA would look at all other impact categories. So human toxicity, eutrophication, acidification. There's a long list, and it depends actually on your product and on your business. So what are the relevant impacts that you have? Those would also be the categories that you'd have to consider.
Thank you for answering this one. And we move to the next. Can you comment on PCF of solvent-borne versus similar waterborne products?
That's a very interesting question. And that is one of the projects that we are now working on with our customers, because it really depends on where you draw the line for your scope. So you could end up with a lower or higher product carbon footprint, depending on if you're looking at up to the allnex gate or up to our customer's gate or even at the end of life. So now we are looking at the customer. In fact, there are some we expect we're not done entirely yet, so don't want to divulge anything, but there might be some unexpected results.
Thank you very much, Sanita, for answering this. Um, Let me check if we have, yeah, we have still some questions. How much of the carbon footprint of a typical material from Allnex can be reduced with biomaterial? Isn't it a slower way to reduce CO2 than by working on your energy intensity reduction?
Of course, you have to work on everything. I'm not sure if it's a slower way, because once you've reduced the emission that you have taken the action, it depends on how you're reducing your plant emissions, and how quickly you can react and change your material sourcing. So it really depends. Yeah, I'll say that's my answer.
Thank you so much. That was the last question for today, Sanita. Again, thank you so much for presenting, for answering these questions. Well, everyone, thank you for asking your questions. And with that, I would like to conclude the session and invite you to the next one. See you there in a couple of minutes.
All right.
Thank you,
Thank you.
Sanita.
Thank you very much.
Bye.
Bye.